You were probably just told to accept this one. Two negatives make a positive. No reason given, just a rule to write down and remember before the test. People have even made up little rhymes so they'd never have to explain it. So let's actually find the reason. It turns out to be a good one, and once you see it, the rule stops feeling like a rule at all. Start with a simpler question. What does a negative sign actually do? Forget multiplying for a few minutes and just think about direction. Picture the number line with 0 in the middle. Positive 3 sits 3 steps to the right of 0. Now put a negative sign in front of it. That sign doesn't make the number smaller, and it doesn't make it disappear. It turns it around. Negative 3 is the same 3 steps, the same distance from 0, just pointing the other way, to the left. So think of a negative sign as an instruction rather than a thing. It says whatever direction you were facing, face the opposite way. Positive is forward. Negative is an about face. Now here's the question that the whole problem really comes down to. What happens if you follow that instruction twice in a row? You are standing on the number line, facing right toward the positive numbers. The first negative sign turns you around, so now you face left. Then a second negative sign turns you around again. And where are you looking now? Back to the right, back toward the positive side, exactly where you started. Two about faces cancel out. Turn around, then turn around again, and you are facing forward. That is all negative times negative is underneath. One flip, then another flip, landing you back on the positive side. But a picture of someone spinning around is not going to convince anyone who is being careful. So let's make it concrete with something you can actually count. Think about money and think of a negative number as a debt. Owing $5 is negative 5. Now multiplying by a positive number just means repeating something. If you take on a debt of $5 3 times, you have 3 times negative 5, which is negative 15. You are $15 worse off. So a positive times a negative comes out negative. That part probably already feels right. But what does it mean to multiply by a negative? Multiplying by a negative is the opposite of repeating. It is taking away. So negative 3 times negative 5 means taking away 3 debts of $5 each. If someone wipes out 3 of your $5 debts, no cash landed in your hand, and yet you are $15 better off than you were. Taking away a debt leaves you richer. So negative 3 times negative 5 is positive 15. Removing what was dragging you down moves you up. If the story still feels slippery, the numbers themselves will pin it down. Let's build a pattern and just watch where it has to go. Start with the 3 times table, but keep walking it downward, past the point where most tables stop. 3 times 3 is 9. 3 times 2 is 6. 3 times 1 is 3. 3 times 0 is 0. Each step down, the answer drops by 3. There is no reason to stop at 0, so keep going. 3 times negative 1 is negative 3. 3 times negative 2 is negative 6. The pattern never breaks. A positive times a negative is negative, and the ladder shows you why. It was always heading there. Now the real event, let's hold the second number fixed at negative 2 and walk the first number downward instead. 3 times negative 2 is negative 6. 2 times negative 2 is negative 4. 1 times negative 2 is negative 2. 0 times negative 2 is 0. This time, every step down the ladder, the answer rises by 2. So watch what has to happen next. Negative 1 times negative 2. If the pattern holds, the answer climbs by 2 once more, from 0 up to positive 2. And it does. Negative 1 times negative 2 is positive 2. Negative 2 times negative 2 is positive 4. The numbers were never going to let it be anything else. To keep the pattern alive, negative times negative simply has to turn positive. But here is the honest truth. A pattern that looks nice is still not a proof. Patterns can fool you. So let's find the reason that doesn't just feel right, the one that actually forces the answer, with no room left to argue. It comes down to protecting one rule that all of arithmetic leans on. The rule is this. When you multiply a number by a sum, you can break the sum apart and multiply the pieces separately. 3 times the quantity 2 plus 4 is the same as 3 times 2 plus 3 times 4. You can check it. Both give 18. This rule is everywhere, quietly holding the number system together, and we are not willing to give it up. So let's apply that rule to one carefully chosen calculation. Take negative 1 multiplied by the quantity negative 1 plus 1. Look at that sum first. Negative 1 plus 1 is 0, and anything at all times 0 is 0. So this whole expression is 0, no argument there. Now compute the very same thing the other way by breaking the sum apart. -1 times -1 plus -1 times +1. We already settled the second piece. A negative times a positive is negative. So -1 times +1 is -1. That leaves us with -1 times -1 plus -1, and we know the whole thing has to add up to 0. So -1 times -1, with -1 added to it equals 0. There is exactly one number on the entire number line that you can add -1 to and land on 0. That number is +1. So -1 times -1 is +1. It cannot be anything else. And that is the heart of it. Negative times negative is positive because it is the only answer the rest of arithmetic will allow. Suppose for a second you try to insist that -1 times -1 was a -1 instead. Follow it through, and that one calculation we just did would come out as -2 on one side and 0 on the other. The distributive rule would collapse. Equations would give two different answers, depending on how you happen to write them. The number line would tear in half. Everything downstream that depends on multiplication staying consistent would start to fail. None of this was obvious historically, by the way. Negative numbers themselves were treated with deep suspicion for centuries. Serious mathematicians called them false and threw away negative answers to their equations as meaningless. This very rule, two negatives making a positive, was one of the things that made people uneasy about negative numbers in the first place. It took a long time for everyone to accept that these numbers behaved consistently and earned a place in the system people already trusted. So the next time two negatives multiply into a positive, you don't have to take it on faith. Picture the about face. You were facing forward, a negative turned you around, and a second negative turned you back. The rule was never the strange part. It was only ever describing the turn.